Last class we talked about different types of motion. This is the time to recap all these things what I talked. Types of motion of rigid body. I divide the motion of the rigid body into two types. One, translation, pure translation, when angular velocity of rigid body is 0. And here rotation. Here we have non-zero angular velocity of the rigid body. And this translation of the rod, when the rod falls in a straight line, all the points move in straight line. This type of translation is called rectilinear translation, when all the points move in parallel curves or parallel lines, but these lines are not straight lines. This type of motion is called curvilinear translation. It seems as if it is rotating. It's not rotating because the angle made by the rod does not change. The angle made by the rod with respect to horizontal does not change. The angle made by the rod with respect to horizontal does not change. But here there is a difference. All points move in straight lines, parallel straight lines. Here the points are moving along parallel curved lines or curves. So this is called curvilinear translation, the rectilinear translation. Both the cases theta is constant, therefore d theta by dt, that is what we define as the angular velocity of the rigid body, that's equal to 0. Now come to rotational part. A body seems to rotate, a body is said to be rotating when its angular velocity is non-zero, but it doesn't mean that the velocity of center of mass will be always 0. So we define the rotation when the rigid body possesses non-zero angular velocity, and this can be subdivided into two parts. Here is the axis, that's called fixed axis. Fixed axis, here the axis is fixed. You pin the rigid body, it is constrained, fixed axis, rotation. And here there is no pinning, no pivot. This is called pivot or axis, the pivot is fixed. Here there is no pivot, free. As I told you yesterday, this is called free rotation, no fixed axis. And this fixed axis can further be subdivided into two parts. When the axis passes through the center of mass, this is called pure rotation because center mass velocity is 0, but omega is not 0. It may rotate clockwise or it may rotate anti-clockwise. Here, the axis passes through any point other than the center of mass. Therefore, the center of mass velocity is not equal to 0. It will be equal to r into omega. R is the distance between this center of mass and the pivot. Since center of mass velocity is not equal to 0, it has translation. Since omega is not equal to 0, this has rotation. So we have both translation and rotation experienced by this body. This body possesses both types of motion, therefore this is called combined motion. Here omega is not equal to 0, this is not equal to 0. Here therefore it is the combined motion, rotation and translation. But here This is combined motion, this is also combined motion, but here the axis is not fixed, I mean it's not pivoted. This is unconstrained motion. Unconstrained motion. This is called constrained. Some sort of constrained motion. This constrained. When you talk about the constrained motion, in broader sense, when you lift the rod under this toe wall, this horizontal, this vertical wall, this slides and this theta changes. So d theta by dt is omega. And the center of mass or the midpoint of the rod also will have some velocity. Therefore, Vc is not equal to 0. It is translating. And omega is not equal to 0. This is rotating. Therefore, this is also a clear-cut case of combined motion. But this motion is happening under two constraints. This also comes under the category of constrained motion, but it's not fixed axis. It's not fixed axis rotation. It is a broader sense, a constrained motion, but it is not fixed axis rotation. Fixed axis rotation, or you can say here this is pinned or pivoted, the rigid body is said to having a rotation called fixed axis rotation. When the axis is not fixed, that's not fixed axis rotation. Sometimes you may argue that when the body rotates in this way, the axis remains the same or omega remains the same. You may call it fixed axis rotation, but actually it's not fixed axis. You can call it combined motion. Axis in general mean pivoting. Pivoting body. For the case of pivot, when the pivot doesn't move, it is fixed. This is called fixed axis rotation. Sometimes this sort of terminology may differ from author to author, but in general, this is fixed axis rotation, or you can say strictly a constrained motion, and when the pivot passes through the center of mass, this pure rotation, there is no translation at all, because the center of mass velocity is 0. And in this case, in general case, center of mass may move, therefore it is a combined motion, and this is unconstrained, this is constrained. Combiningly, we can call the rigid body to be rotating, because omega of the rigid body or the angular velocity of the rigid body is not equal to 0. That's the basic idea behind rotation. When the angular velocity of the rigid body will be equal to 0, the rigid body seems to rotate, but it's not rotating. All the points are moving in curves. As I told you, a point may move in a curve, it may move in a straight line, it may move in a circle, but you cannot say that it's rotating. So this is a clear-cut case of translation, because theta does not change. So in this way, types of motion of the rigid body, motion means both translation and rotation. And in this case also translation portion is there. Here pure translation we can say, because omega is 0. Here omega is non-zero, center mass velocity is non-zero, so you can call it combined motion, and this is also combined motion, even though this is fixed axis rotation. So these are some terms you need to understand before we go for putting the theory of uniform accelerated motion of the rigid body. There are two types of uniform acceleration. If I release the body, its center of mass must move with uniform acceleration. Motion of a point or particle or point mass is called translation. The center of mass translates with uniform acceleration, that's equal to 9.8 meter per second square towards Earth's surface. This is called uniformly accelerated translatory motion. But when a body rotates with uniform angular acceleration, we call it uniformly accelerated rotation or uniformly rotating object having a constant or uniform angular acceleration. This is also called uniformly accelerated motion in rotation. When alpha remains constant, I will derive a set of equations the way you derived in your linear kinematics. S equal to u plus half at square, v equal to u plus at, v square equal to u square plus 2as. Similar set of equations in angular parameters. You are using the angular quantities or parameters like angular velocity, angular acceleration, angular displacements. I am going to derive all these equations now one by one.